Hi everybody, we are now going to solve exercise 8, chapter 11, externalities. Okay, so we have a perfectly competitive market, 100 companies, as you can see here, firms are symmetric. This is the total cost function, 250 Qi plus Qi square, where I obviously stands for 1, 2, 3 up to 100. We have the market demand, and then we have the external cost, okay? Because the production of this good Q generates pollution. So we are in the case of negative externality. First point, compute the supply curve of the single competitive firm and the market supply curve, okay? So we are not taking for the moment the negative externality into account. We have to compute the supply function of the single firm, okay? So supply curve of the single curve, okay? So we know that to find the supply curve of the single competitive firm, because we are under perfect competition, we need to basically consider the following situation. So this is how we denote the supply curve of the single firm with little q, is. This will be equal to the price equal to the marginal cost if the price is larger or equal to minimum average cost, or in the opposite situation, so price lower than minimum average cost, it will be equal to 0. So the firm will supply a 0 quantity. So first of all, we have to find the marginal cost. Okay, so we start basically finding the things we need to set up this supply curve. Okay, so let's start with the easiest one, marginal cost. Okay, to find marginal cost, we simply compute the derivative of the total cost function that depends on Qi with respect to Qi. Okay, and if you do this, you take the total cost function that we are given. It's very simple. You end up with a marginal cost equal to 250 plus 2 times Qi. Okay, so you compute the partial derivative of the total cost with respect to Qi. Okay, so we have the marginal cost. Now we need to find the minimum average cost. Okay, so that's the second step, minimum average cost. Okay, and to find the minimum average cost, we need to set up the equality between marginal cost and average cost. We have marginal cost, we don't have average cost. So here the first thing I need to do is to compute the average cost function. But that's again easy because I just take the total cost function and I divide it by Qi, okay? And so you get that this is equal to 250 plus Qi, okay? So to compute the average cost function, I take the total cost function and I divide it by Qi, okay? Now I can set up the equality between marginal cost and average cost. And so I have 250 plus 2 Qi equal 250 plus Qi. This we can get rid of them here, and we end up with Qi equals 0. This is the quantity that minimizes average cost, but obviously it is not minimum average cost. So to find the minimum average cost, I substitute this quantity that I have found here either into marginal cost or into average cost. It's the same, okay? So we have minimum average cost equal, suppose we use marginal cost where we substitute this 0, but again, I would obtain the same result if I use now here average cost of 0. And so I get 250 plus 2 times 0, so 250. That's the minimum average cost, okay? Okay. So now I have basically, going back here, the minimum average cost, I have the marginal cost. Now before writing everything in a precise way, I need to set up the equilibrium condition, price equal marginal cost, okay? And this is exactly what we do now, okay? The next step. Okay. So we have, now we set up the equality and we have price equal marginal cost. Okay. So price equal 250 plus 2 times QI. So 2QI equal P minus 250. And so now it's very easy to get out of this the supply function, Q of the single firm, that is P minus 250 divided by 2. Okay? So now I can write, what's the supply curve of the single competitive firm is. Okay? So let's write it. And I write the supply curve of the single competitive firm is given by, so we write QIS equal to P minus 250 divided by 2 if the price is larger or equal with respect to our minimum average cost that we have just found, 250, or 0 if the price is lower than 250. Okay? And this is the first result. But we were also asked to compute the market supply curve. Okay, so the market supply curve, given that we know that N is equal to 100 because we have 100 firm, it's easy because it is given by QIS is given by N, that in our case is 100, times little q. Okay, so 100 times QIS, and so we rewrite this in a precise way, and we get that QIS is given to 100 times P minus 250 divided by 2 if the price is larger or equal than 250, okay? Here we simplify, okay? And then we will write the final result, okay? Or we have 100 times 0 if the price is lower than 250, okay? So we can write the final result for the market demand as, and we write it here now. So basically we have that QIS is equal to 50p minus 12,500 if P larger or equal than 250, while 0 if P lower than 250. And we are done with this first point. Okay? Okay. And now we move on. We move on to point 2 of the exercise, where we are asked to determine the equilibrium quantities in terms of price and sales. So the price and the quantity, okay? So we know that the competitive equilibrium, again, the externality is not taken into account yet. It will be later on, don't worry. The competitive equilibrium is given by quantity supplied equal to quantity demanded. Okay, market level, obviously. So we simply substitute and we have 50p, we have just found it, minus 12,500 equal to the quantity demanded that we are given, 75,000 minus 50p. If you compute, you get 100p equal 87,500. So our equilibrium price, competitive firm, is 87,500 12,500 divided by 100, and so 875. The quantity produced at equilibrium by the competitive firm under this scenario is easy to find. We just substitute basically the price that we have found into either the demand or the supply. It's basically the same, okay? So we have 50 times, for example, let's use the demand, sorry, the supply, I mean, it's the same, 50 times equilibrium price minus 12,500, okay? So you substitute 875 minus 12,500, and you get 31,250, okay? And this is point 2. We are done because we were asked to compute the equilibrium in terms of the price and the quantity. This is what the company producing the negative externality will produce, and at what price, you know, if the company is not forced to take the negative externality into account in any way. Okay. Now, number 3, we have to compute the consumer surplus and producer surplus at this competitive equilibrium. So here the best, easiest way to go is to graph. Okay. So let's graph it together. You have Q here, you have P here. Okay. We need to graph QS and QD. Okay. Let's rewrite the equations. Okay. So we have QD is equal to 75,000 minus 50p. Okay. And then you have QS that is equal to 50p minus 12,500. As usual, we graph these lines because they are lines computing the intercepts. Okay, so for the demand, the horizontal intercept is obviously 75,000. 75,000. Let me rewrite it using another color. Maybe it's more clear. I guess so. 75,000. And the vertical one is 1,500. Okay, so this would be basically the demand. Okay, I write here QD. Now QS. QS is equal to 50p minus 12,500. Okay, so here, I mean, the horizontal intercept would be negative, so we don't really represent it. We let the line start from here. For example, this is QS. Okay, this value here, if you compute it, is 250. And now we have here the equilibrium quantity, 31,250, and here the equilibrium price, 875. Okay. Now it's kind of easy because we have the producer surplus and the consumer surplus. So this is the producer surplus, and this up here is the consumer surplus. Okay, producer surplus. Okay, so the consumer surplus is basically this part up here that I will color in pink. Okay. Okay, now it's easy because we just need to compute the areas. Okay, so it's just a matter of computing the area of two triangles. So let's start with computer surplus. For computer surplus, we have 1,500 minus 875 times the quantity, 31,250 divided by 2. And you get a huge number, Let me write it. It's 9,765,625. Okay. Producer surplus, you compute again the area of the triangle, and this time you have 875 minus 250 times again 31,250 divided by 2, and you get the same huge number. Okay? And we are done with this point 3. Now, we can move on to point 4. Point 4, now we start with taking, let's say, the externality into serious account, because we are asked to compute the socially efficient level of output, because we know that in this case we have a negative externality. Let's rewrite it, negative externality. And so we know that the quantity produced will be larger, this quantity that we have just found, with respect to the socially efficient level of output that we denote with 2 stars. Okay? So under a negative externality, we produce more than what would be the optimal social level of output. Okay? So let's see, basically, we have to compute this Q star, double star. How do we compute the socially efficient level of output? We set up the equation marginal social cost will be equal to marginal private cost plus marginal external cost. Okay? So Q is the quantity that makes this equation be satisfied, because the social efficient level of output allows marginal social cost to be equal to marginal private cost plus the external cost, because I take the external cost into consideration. I don't have this, but I can compute it, because this is the derivative of external cost with respect to QI. And so it is given to 50, it is given by 50 plus 2 QI, okay? We were given external cost at the beginning, so it's really easy. We just compute the partial derivative, okay? So really easy. Now, we can set up the equation, because we can write marginal social cost equal to marginal private cost is equal to marginal cost. We have already computed it, 250 plus 2 QI plus this thing here, 50 plus 2 QI. And so you get the marginal social cost is equal to 300 plus 4 QI. Okay? And that's the first little result that we have. We have found the marginal social cost function. Okay? Now, in order to find this Q double star, so this social efficient level of output, we need to compute, to set up the equilibrium condition in this case, that is price equal marginal social cost, because now we want the socially efficient level of output. And so we have P equal to 300 plus 4 QI. And so in this case, the supply function will be given by P minus 300 over 4. Okay? Okay, so this is basically the supply function of the firm that takes the negative externality into account. Okay? From this, this is of the individual firm. So now we can compute the market social supply curve. So the supply curve of the market that takes into account the externality and hence leads to the socially efficient level of output. Okay? And it is enough to have to multiply times 100 the individual one, because we have symmetric firms. Okay? This is 1, this is 25, simplifying. And so we get QIS equal to 25P minus 7,500. Okay? But we are not there yet. Okay? This is the market supply curve, but now we need to set up the equality in order to find the equilibrium. We need to set up the equality between this market supply and the demand. And this is what we do now. Okay. So now we set up the equality between QS, this QS here, and QD. Okay. So we get 25p minus 7,500 equal to 75,000 minus 50p. And now we can finally find the efficient price. We call it double star to make it different with respect to the previous one. And this will be given by 82,500 divided by 75. And it gives 1,100. And now it's extremely easy to find the Q double star, so the socially efficient level of output, socially efficient, socially efficient level of output produced by the market, because this is at a market level, by the market. To find it, we simply substitute this P either in the demand or in the supply. It's the same. Suppose we substitute it into the demand. We have 75,000 minus 50 times 1,100. And this gives 20,000. As you can see, this quantity here, as we said at the beginning, is lower than the quantity produced by the firm that does not take the negative externality into account. Okay? And we can also compute the socially efficient level of output produced by the single firm. Okay? So socially efficient level of output produced by the single firm. And this is given by our totally efficient, the social efficient output produced by the market divided by the number of firms. So we have 20,000 divided by 100, and this gives 200. Okay? And we are done with point 4. Okay? So it would be socially efficient to produce 20,000, but if the firm is left alone, it will produce more than 31,000. Remember the output the level of output we discovered before. Okay, now, final point, that's number 5. We have compute the rate of the Pigouvian tax that should be levied introduced to induce the sales of the social efficient level of output. Okay, basically we have to find the tax rate of the Pigouvian tax. So let's first recall what the Pigouvian tax is. So basically the situation is the following. There is this negative externality. If nothing is done, then the firm just produces the quantity, we found in the first points, okay, 31,000 and something. But the social efficient level of output would be 20. So the government, as a public agent, can intervene and basically make the firm produce the socially efficient level of output. How? Introducing a tax, okay? And the tax is, if the tax is Pigouvian, then the firm will produce exactly the socially efficient level of output, okay? So let's write it. The Pigouvian tax leads to the production of the socially efficient level of output by the single firm. Okay, and we know that we have a Pigouvian tax when its tax rate is exactly equal to the marginal external cost caused by the externality. So in our case, we have already found it. It is 50 plus 2 times Q. And since I want to find the Pigouvian tax here, I have to substitute the social efficient level of output produced by the single firm. So I have T equal 50 plus 2 times 200. The level of output produced by the single firm when this level of output is socially efficient. Okay? And so the tax rate should be 450. Okay? And we are done, because this is the social, basically, if the government introduces a tax rate of 450, then the firm will produce exactly the social efficient level of output that is equal to 20,000. And we are done with this exercise.